Welcome. Here's the lesson for Unit 3, Section 6, which is about lines in the coordinate plane. Missy McCarthy, Okemos High School math instructor. There are three types of equations of a line that we're really going to focus on. The first type of equation of a line is called point-slope form. The point-slope form of a line is y minus y1 equals m times x minus x1. In this equation, m represents the slope of the line, and x1, y1 represent any point on the line. So if you have the equation y minus 3 equals 2 times the quantity x minus 4, the slope is here. The slope of that line is 2. And then the point x1, y1 is 4, 3. I'm sorry, this is actually incorrect. It should say the x coordinate, x1, is here, so it's 4, and the y coordinate, oh, didn't mean to mark that out, y1 is here, so the point should be 4, 3. Another way that we can write the equation of the line is in slope-intercept form, which is y equals mx plus b, where m in this equation is the slope and b is the y-intercept, or where the line crosses the y-axis. So in the equation y equals 3x plus 6, the slope of that line is 3, and the y-intercept, or where it crosses the y-axis, is 6. Lastly, the equations for verticals and horizontal lines are neither in slope-intercept or point-slope form. It is simply x equals some number a, where a is the x-intercept, x equals 5, would end up being a vertical line. And the equation for horizontal line is y equals b, where b is the y-intercept, so y equals 2. So there are main forms of the equations of lines that we're going to use. So here, if it says write the equation of the line in the given form. So we need the equation of the line that has a slope of 6 that passes through the point 3, negative 4 in point slope form. So just to recall, point slope form is y minus y1 equals m times x minus x1. So we know the slope and we know y1. y1 is negative 4, so y minus negative 4 equals the slope is 6. And then x minus x1, which is 3. We can simplify this a little bit and we would end up with y plus 4 equals 6 times the quantity x minus 3. And that's the equation of that line, the line that passes through the point 3, negative 4 that has a slope of 6. For part B, it says write the equation of the line through the points negative 1, 0 and 1, 2 in slope-intercept form. So slope-intercept form is y equals mx plus b. So the very first thing I need to find is the slope. The slope is the change in y, or 2 minus 0, over the change in x, 1 minus negative 1. So we end up with 2 over 2, so the slope is 1. So that gives us the equation y equals 1x plus b. Now to find b, what we usually do is choose one of our points. So I'm going to choose this point here, and I'm going to substitute it in for x and y because it's a point on the line, and find the value of b. So if we go there, now we have y is 0 equals 1 times a negative 1 plus b. So 0 equals negative 1 plus b, and b is equal to 1. So the equation of the line in slope-intercept form is y equals 1x plus 1. You can also graph the equations if you've got the point, if you've got the slope, and then all you have to do is connect the points and draw the arrows in both directions. So let's practice with that a little bit. Here we're going to graph the line where the slope is 1/2. This is in slope-intercept form, so the slope is 1/2, and the y-intercept is 1. So the y-intercept is 1. The slope says rise 1, run 2. Rise 1, run 2. And if we connect those, we have the line, the graph of that line. Now here's another one. This one is in point slope form, so we've got to take a look at what the slope is. The slope is negative 2. And this would be x minus a negative 4. So x1 is negative 4, and y minus y1, which is 3. So we've got the point negative 4, 3, and the slope is 2, down 2 over 1, down 2 over 1. we can draw the line, and there's the graph of that line. This last one here is either a horizontal or a vertical line. It's y equals -3, so the y-intercept is -3. That's here, and it is actually a horizontal line going straight across there. Y equals -3. Now, for lines that are parallel, these are lines that are going to have the same slope but a different y-intercept. Remember, a few lessons ago we said parallel lines have the same slope. If lines are intersecting, they're going to have different slopes. It doesn't matter what the y-intercept is, but if they're going to intersect, they have different slopes. And lines that are coinciding lines, which really mean the same line, if you graph them, they're right on top of each other, they'll have the same slope and the same y-intercept. So here is our last slide. We're going to take a look at whether or not these lines are parallel, intersecting, or coinciding. So I look here, and this has a slope of 3, and this one has a slope of -3. So because they have different slopes, that means that these lines are intersecting lines. Okay, if we look at this next example, this one isn't quite in slope-intercept form where this one is. This one I can identify the slope is -1/3. I would have to divide everything by 6 to get y equals -1/3 x plus 2. And what I notice is that these lines have the same slope, and they also have different y-intercepts. So that means these are parallel lines. And then lastly, this line I would need to solve for y, so I would have 2y equals 4x plus 16 and divide everything by 2, which would give me y equals 2x plus 8. And so the slope of this line is 2. The slope of this line is also 2, and it's in point slope form, so I need to figure out what the y-intercept is to see if they're coinciding or parallel. I would distribute this 2, and I would get y minus 10 equals 2x minus 2. And then add 10 to both sides. And so that would give me y equals 2x plus 8. So we find that they have the same slope and the same y-intercept. So these lines are actually coinciding. And there you have it.